So several questions here. The first one says, explain what it means for a graph to be symmetric with respect to the x-axis. So what does that mean with respect to the x-axis? So if I have a point up here, it's got to have a mirror image down there. So we could have a situation like this, coming in like this, coming in like that. So if you'd fold it over, right, if you would take your points and fold them over the x-axis, they would match. That's what symmetric with respect to the x-axis means, right? Fold over x-axis. Points match. The next question that they're asking us to look at is, what does it mean for being symmetric with respect to the y-axis? Okay, well, same argument. If I have something here, I've got to have the equivalent thing over on that side. So symmetric with respect to the y-axis tells me if I fold over the y-axis, the points match. So you should be able to look at graphs and determine whether or not they are symmetric with respect to the y-axis or symmetric with respect to the x-axis. Our third question asks for, what does it mean to be symmetric with respect to the origin? Now that's a little trickier. So let's talk about that. If I have this point here, I fold it this way first and then I fold it that way. So this point is counterbalanced with this point. If you fold it twice, symmetric with respect to the origin, fold over both axes, fold over y-axis and then over x-axis, or x-axis and then over y, which was the example I gave you. Fold over x-axis and then over y-axis. Points match. So this point would have its partner point over here. So you'll notice that this might be the point A, comma B. This point over here is what is negative A, comma negative B. That gives you an idea about how that is going to work. All right, what are they asking next? Explain the technique to determine if something is symmetric with respect to the x-axis. Well, here's the idea. What's our technique for determining if a graph is symmetric with respect to the x-axis? So I have this point and I have this point. For example, this point might be what? It might be 5, comma 1, and this point might be 5, comma negative 1. You'll notice the y values are opposite of each other. So y and negative y are both there in a sense. So to determine if something is symmetric with respect to the x-axis, you replace y with negative y. If the equation is the same, the graph is symmetric with respect to the x-axis. So an example of that would be something like x equals y squared. If I replace y with negative y, what happens? Well, the equation now becomes x equals negative y squared, but negative y times negative y is the same as x equals y squared, same as the original. So you can see that. Let's go to Desmos if we can, to see what does x equal y squared look like. We replaced y with negative y and we have the same thing. Notice symmetric with respect to the y-axis is what we have there. All right, what is our next question? Explain the technique to determine if an equation is symmetric with respect to the y-axis. Okay, so symmetric with respect to the y-axis. So this point matches this point. So this might be the point A, comma B. This would be the point what? negative a comma b. So that gives you the idea that x and negative x give you the same y value. So the strategy here is replace what? Replace x with negative x. If the equation is the same, the graph is symmetric with respect to the y-axis. So an example of that might be something like this: y equals 2x to the fourth plus 3x squared plus 7. If I replace x with negative x, y equals 2 times negative x to the fourth plus 3 times negative x squared plus 7. What do I get? I get y equals negative x to the fourth is the same as x to the fourth, because negative, 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 negative is positive. Similarly, negative x is x squared. So if we graph this thing, it should be symmetric with respect to the y-axis. So let's take a look at Desmos and see if it is. We said y equals 2x to the fourth plus 3x squared plus 7. And sure enough, if you fold it over, right, if you fold it over the y-axis, the points match. So that looks good. The next one says, explain the technique used to determine if an equation is symmetric with respect to the origin. That's a double fold. So symmetric with respect to the origin. So what's our strategy here? Right, we have a comma b, negative a comma negative b. And our strategy here is replace x with negative x and y with negative y. Replace x with negative x and replace y with negative y. If the equation is the same, the graph is symmetric with respect to the origin. So an example of that would be something like y equals 2 over x. So we'll replace x with negative x and y with negative y. So y becomes negative y, x becomes negative x. Now I get negative y equals 2 over negative x. Multiplying both sides by negative 1, we are back at the original equation. It's the same once we simplify it. So can we see that if we look at the graph? So let's go to Desmos, y equals 2 over x. We see if we do a double fold, the points match up, and sure enough, fold it over the x-axis and then fold it over the y-axis. I think you can see this point here, 2, 1 comes down here, becomes 2, negative 1 becomes here, becomes negative 2, negative 1. There we go. So a double fold is going to go ahead and work. That's what we mean by symmetric with respect to the origin. All right, what else do we have? An even function is symmetric with respect to what? An even function is always going to be symmetric with respect to the y-axis. Now think about it, if you're symmetric with respect to the x-axis, you're probably not a function because you're going to fail the vertical line test. An odd function is symmetric with respect to the origin. And what does it mean for a function to be even and a function to be odd? Well, that indicates it to us a little bit, right? Even, we're saying, is symmetric with respect to the y-axis. So if I have a point here, if I have this point as x, f of x, if it's symmetric with respect to the y-axis, this point over here, negative x, has to have the same value. So this f of negative x has got to also be f of x. So if they're going to have the same height, an even function will be if f of negative x is the same as f of x. Now, in the case of an odd function, here we have x, f of x, it's symmetric with respect to the origin. Here we have negative x, f of negative x. Well, how are they the same? Well, they're not the same. In this case, f of negative x is the negative of f of x. For an odd function, f of negative x is the negative of f of x. That will give us our symmetry with respect to the origin. Odd is symmetric with respect to the origin. Okay. And that finishes the problem.